Bottlenecks. I myself know if I have a bottleneck or not because I definitely know my system and I know my shit. So if I see, for example, the GPU power draw going way lower than expected, even if the GPU usage, let's say, is at 99%, I know that there is something wrong maybe with the drivers, or then I have a CPU bottleneck or RAM bottleneck. Like I said before, that's one thing that I know, but how can I exactly show you that? How can I show you, for example, on a graph that there is a CPU bottleneck besides telling you that, okay, if the GPU utilization is low, you might have a CPU bottleneck or RAM bottleneck? Intel just made that easy. With their latest version of Intel PresentMon, the beta version that they just released some days ago, you actually have one new feature called GPU Busy, one new metric actually called GPU Busy. And that same new GPU Busy metric is what actually allows you, while watching both the frame times and the GPU Busy at the same time, what actually allows you to see in real time if you have a CPU bottleneck, CPU/RAM bottleneck or not, if there's something that the CPU is actually doing while the GPU is actually sleeping or not, and that is one of the most interesting metrics that I've seen so far. And I mean, not even mentioning that Intel's PresentMon is actually free to use, works on all GPUs, AMD, Intel and Nvidia, and is basically not only free to use but also free for the developers because it is open source. And if you don't really know, from my understanding, the frame times actually show you the time that the CPU takes to make a frame, while the GPU Busy, the new metric GPU Busy, actually shows you the time that the GPU takes to make a frame. So if you have the GPU, or the CPU in this case, if you have the CPU taking way more time than the GPU to make a frame, it means that you have a CPU/RAM bottleneck. But now you can see those in real time with some frame graphs, and I'm actually gonna show you. Today's video sponsor is GVG Mode, bringing you all the software deals you need, like Windows 10, Windows 11, Office 2021 with a new Windows 11 design, and even Windows Server 2022. For all of these, you can use my SKG discount code for 25% off, getting a Windows 10 serial key for only $16. Then use the key on your Windows settings and you'll have an activated system. Opening the software, you are actually presented with several things. So we have the process here, which is the process that it's running or not, and we have the auto target process. So if you're running, let's say, two games or two processes, you can actually manually target the process that you want the software to pick. If you have, for example, the wallpaper engine running on the background, it still uses GPU power, but if you have a game running on top of it, it will target the game because the game has higher GPU usage. So that's a very nice thing. We also have the overlay hotkey to enable or disable the overlay, and then we have several presets. We have basic, GPU focus, power temp, and custom. We come with the basic, but I was already testing this before because I was obviously gonna test this before showing you, and I have the GPU focus right now. Then we have, for example, the capture duration, because we can indeed define a standard duration for our capturing, for our metrics capturing, and then we have the capture hotkey that I already changed to the letter 9, in this case to the number 9, not the letter. And then we have the capture storage, which allows you to open in the Explorer the benchmarks that were done before. So we have lots of metrics. For example, if you do those benchmarks, you can get, for example, the simplest one. We can go, let's say, like this, and you have the simplest one with duration, total frames, average FPS, minimum FPS, 99th percentile, which is basically the 1% lows, 95th percentile, and then the maximum FPS. So this is the most basic one. But if you want to do those graphs yourself, for example, with the 1% lows, with the average frames, if you want to do those graphs, you have this bigger file that you can open as well, and you have lots and lots of data. As you can see, it's insane the amount of data that we have here. Okay, this is the basic. Then we have several settings. For example, we have the settings of the overlay, whether we have the overlay, for example, in window mode or not, because if you select, for example, the window mode, you can change or you can use, for example, the overlay outside the game. For example, as we're running Counter-Strike 2, we have all the metrics here. They are actually very nice. And as you can see, the GPU, the GPU default already tells you here, it gives you the frame time average and gives you the GPU busy average. But going back to the windowed mode, you can select the window mode, then we can have the PresentMon here on the side, even if the game is running, and the results will be there, as you can see. This is especially good if you are running, for example, a dual monitor setup and you want to have the game in one monitor and the PresentMon, for example, in another, which is a very nice thing because you can see the metrics in real time in dual monitor setups or triple monitor setups. Doesn't really matter, but it is really a nice addition to have the windowed mode, for me at least. Very, very nice. And of course, as soon as we disable it, bam, it goes back to the full screen mode only. We also have the automatic hide, which automatically disable the overlay during capture. And this is a very nice thing actually, because for example on the AMS Afterburner, when I start capturing, the average FPS and the 1% lows will appear. So I always know that the MS Afterburner is capturing the results. Something that we cannot make that automatically. You need to configure MS Afterburner in order to do that. But in terms of the overlay configuration here with PresentMon, you can actually do that automatically. The results won't show, but the overlay will get automatically hidden when you're actually capturing the results. And that's a good thing for two reasons, because the first one is because you know that the results are being captured, and the second one is because the overlay is not taking a toll on your FPS numbers. So for me, it's a win-win situation, definitely. Then we can also choose the position of the overlay. We can choose, for example, top left, top right, bottom left, and bottom right. We can choose them the default position, let's say that, if you're not using the windowed mode. Then we have the width, which is literally the width of the thing. So let me show you here, because it's way easier to show you with the windowed mode. So we can select the width, as you can see here.
Thank you, kind sir.
And then we have the time scale, which is basically the amount of seconds that you have in the graph. It comes default at 10 seconds, of course. You can select, for example, 1 second, and you'll only have 1 second in the graph, as you can see, 0 and 1, only 1 second, but you can see the data as much as you can with a 10 seconds graph. So I absolutely have to advise you to keep it at 10, because you have 10 seconds to see the data. It's much better, much better. Then we have the time scale. Time scale not, because we already saw that. Then we have the graphics scaling. So we basically can select the graphics scaling in order to increase the size of the layout. If you're running, for example, an extremely high resolution and the graphics layout is too small, then you can select the factor increase, for example, to 1.5. As you can see, it is already much bigger. As for the draw rate, closest valid rate will be targeted. Depends on the metric sample period. This is actually one of the things that I did not understand. I won't say that I did, because I did not. But well, if you do know what this makes the draw rate, well, just let me know in the comment section, because I always like to learn. So as you can see, we're running now Counter-Strike 2, and there are some really interesting things, by the way. For example, this CPU is very, very good, and we have no CPU. We are running at, let's say, 700 FPS, but we do not have a CPU bottleneck here. As you can see, for example, the frame time is 1.50 milliseconds, and the GPU busy time is 1.22, so it's basically the same. That means that there is indeed no CPU or GPU bottleneck. In this case, let's say that the build is very, very well stabilized, well balanced, and things are running perfectly fine. Oh, it's camping here. Okay, as you can see, the results are very close to each other, which is a very, very good thing. You have also the frames, the GPU utilization, the voltage, and so on. Even the memory, the GPU memory used, and once again, the GPU, the frame time, and the GPU busy time are more or less on par. Now, I'm already at 1080p. Imagine if I actually try to render something, let's say, at 720p or even lower than that. Let's use the upscaling technology. it will look horrendous. But let's just try to see how it goes. Let's try, for example, to the balanced mode. We're trying balanced mode at 1080p, meaning that we're rendering like 540p or something like that. As you can see, the values are still quite okay. They're a bit different, okay. A bit slightly higher to the frame time. We have a limitation because the GPU utilization is at 80%, but still the frame times and the GPU busy times are quite lower because the resolution is just too low and there's not much we can do. But this is still a CPU bottleneck, but the frames are so high that the difference is really small. So for example here the frame time is 0.92 and the frame time average is 1.30, so the difference is indeed there, but the amount of frames is so big that I believe that that's the actual issue. So it seems that Counter-Strike 2 doesn't show the actual difference because well, once again we're running CS2 and it's still in beta and may have some issues, and once again it's a lot of FPS, so maybe we can see, because from what I understand I believe that the GPU busy in between the difference in between frame time and GPU busy shows you if your system is unbalanced, because you might still have a CPU bottleneck. From what I understood here, you might still have a CPU bottleneck, but and there are see the difference here. For example, you saw that little mountain there. It means that the CPU was indeed loading something, and I believe it was the textures, and that's where we saw some. Once again, look at the difference here. So we have the GPU doing its job, but the CPU is loading shit. So the frames were lower because of that. So yeah. It was a nice decision to actually show this. Basically, this shows when the GPU, the difference in between the GPU busy parts and the CPU busy parts. Once again, frame time versus the GPU busy. As you can see, if you were having a massive CPU bottleneck where the CPU couldn't really handle the job, because I have a 7700X, but if the GPU couldn't really handle the job all the time, like for example Intel showed with the i5-13400F, you would see differences in between the GPU busy and the frame time. Or if, let's say, the GPU driver is very bad in that scenario, you would see differences in those scenarios as well, because the GPU would constantly be sleeping because the CPU wouldn't be able to deliver the frames that the GPU needed. So instead of having only the lower GPU utilization, you would also have the CPU being completely broken in that scenario. Let's try, for example, 1080p to see if there are actual differences. It's hard to see with the overlay. So let's see 1080p to see how this goes in terms of frame time and GPU busy. Okay, you can see a small difference once again, but as we're loading new parts, we can see that the differences in between the frame time and the GPU busy are actually getting bigger. Yeah, as we can see, so the GPU busy is around 8 milliseconds, while some of the frame times are around 10 milliseconds, and this is because the CPU is loading the assets, most likely the textures, the shader cache, something like that. Hence why we have the differences, and this is what Intel actually brought the GPU busy in between frame time, so we can see that the CPU is having to work a lot more at 1080p. In this case, the CPU is having to work a lot more than the GPU, and the CPU is having a tough scenario. Okay, my bad. Bam. Yes, I don't play this game for quite some time, so it's normal that I'm rusty. Bam. Yeah, I'm doing a very bad job actually. Okay. But yeah, as we can see, we have a slight variation that we did not have on CSGO and some other games, because once again the CPU is doing a different job. As we start, for example, settling down, as I stop, the CPU has way less work to do, and as you can see, yes, the frame time and the GPU busy averages are more or less the same, practically identical. As soon as I start moving, and the fastest I move, the worst, as you can see, the differences in between the GPU busy time and the CPU busy, and in this case the frame time averages start being, well, they get bigger, so. And yeah. And as you can see, if I stop moving, for example, the GPU busy time and the frame time averages, they are more or less the same. So 8.37 on the frame time and 8.33. But as soon as I start moving, those differences start appearing, with the frame times being considerably higher than the with the frame times being considerably higher than the, okay, you're dead. Bam. Being considerably higher than the GPU busy time, meaning that it's the CPU that is actually holding back the GPU in this specific scenario. Maybe once again due to texture loading, GPU shader cache loading, something like that. But as you can see, there is indeed the difference. As we go into a new area, we can see that the CPU is actually doing its work. It's loading something while the GPU is almost in a flat line. Interesting, actually, interesting. And basically this is what Intel brought to the market with Intel PresentMon new update, and it is actually pretty interesting, as you saw. So in games like CSGO, we do have low GPU utilization when using, for example, upscalers. We do have GPU utilization, meaning that the CPU could do a better job. If we had a better one, we would most likely have more FPS, but the CPU and GPU were well balanced. The game was not doing anything to the CPU in the background. But as soon as we went, for example, in a newer game, in a heavier title like Jedi Survivor, we could see the differences in between the frame time and the GPU busy time, meaning that the CPU was doing a lot of work in the background, most likely once again loading textures and so on, and the GPU was going into a flat line and the CPU was going like this, meaning that it was doing something and it wasn't able to deliver more FPS. And in that scenario, if we had, let's say, frame spikes and so on, it was once again due to the CPU. If the spikes were more or less the same with the GPU time and the CPU time, it means that the spikes could be CPU or GPU wise, but this is not the case, since the spikes were only on the, or at least the frame variations, the millisecond variations were only on the frame times. It meant that it is indeed the CPU, and that's one of the biggest things that the GPU busy feature actually allows us to see, because it allows us to see in real time if the stutters that we're having are due to the GPU or the CPU. And if you want to see more examples, Intel actually gave us one. For example, their launch drivers, the 3490, had a huge CPU overhead. So the issue was not the CPU per se, because the CPU was fine, but their drivers had a huge CPU overhead, leading to the CPU performance to be much worse than it should. And for example, on their launch drivers, the 3490, even with the 13400F and the Artic 750, which is not that powerful, so the 13400F would be more than enough in any game to stress out the A750, meaning that a CPU bottleneck should not happen at least, and yet we can see that the CPU bottleneck is happening here, with the frame times being much higher than the GPU busy time. As you can see, the GPU busy in yellow. In this scenario, for example, in here and in here, or even in here, we can see that the frame times are way higher, meaning that the CPU isn't able to do the work properly. Something that was fixed, of course, in the newer Intel drivers, because the lines are now more or less on par with each other, and it shows on the Intel presentations. So the GPU busy does not only allows you to see if you have a CPU bottleneck or a GPU bottleneck, but allows you to see in real time if the stutters that you're having once again are CPU or GPU related. And that's a very, very nice and very, very interesting thing. I'm eager to see where things are going, if MS Afterburner will also implement the GPU busy time and so on, because these things are, and this thing, mostly the GPU busy, is really interesting. Thanks a lot for watching, guys. Don't forget to like, subscribe, and share this video. If you have any comments that you want to leave, if you have any doubts, just go to the comment section, leave them there, and I'll answer as fast as I can, as usual. But this is a really interesting thing to be able to see in real time where the stutters are coming from. That's a very nice thing. That's a very nice addition indeed. And the layout also looks cool, so it's a win-win situation in my opinion. But once again, thanks a lot for watching and see you in the next video, guys.